Hey, this is Jesse with Create This. This past week, I have been working on a new project. This is my solar generator. In 2015, you might have seen some videos that I had about the Goal Zero Yeti 400. I've been using that for about half a year. This one is substantially more capable. So I have a real charge controller this time. This is a Midnite Classic 150. It might look like plastic on the camera, but this is all like cast aluminum or something. Cast iron maybe, I'm not sure. It's probably cast aluminum so that it doesn't rust. But it's very heavy. I assume that it dissipates heat pretty well when sunlight's not directly on the black material. Anyway, so this is my charge controller, and what this allows me to do, you might see right here, it's pulling in 28.5 volts MPPT. So this is an MPPT charge controller versus the Yeti 400's PWM. And it's pulling in 11 watts right now. And that's pretty awesome. It's completely overcast today. I'm using two 100-watt solar panels, 12-volt solar panels. And the great thing about this charge controller is it's got like a 150-volt upper limit of the input. So I can actually wire my solar panels in series. I think with these 12-volt solar panels, about the most that I can wire in parallel without exceeding the 10-gauge PV cable limits for the amount of distance that I'm running in cable is two solar panels. I think I can only run two in parallel. So the limit with the Yeti 400 was two solar panels because I could only run them in parallel. I couldn't run them in series. But with this charge controller, I can actually run them in series, which is pretty cool. You can see that the resting voltage of the solar panels is 41.1 volts. This charge controller all by itself pulls about 5 watts all the time when it's on. So it pulls considerably more power than the Yeti 400's PWM charge controller. I think that thing was probably measured in a watt or less. But this thing pulls a substantial amount of power just being on. So in order to offset that, I think you need two things. You need a bigger battery. You know, the Yeti 400's is a 400 watt hour battery. It's AGM. So you can only use 50% of that capacity if you want your battery to last any reasonable amount of time. That gives you 200 watts, right? 200 watt hours. So with this thing, you would burn through 200 watt hours pretty quickly with it just drawing 5 watts in standby. I think with a system like this, you need a bigger battery and you need more solar panels in order for it to make sense. Now, I only have two 200-watt solar panels right now. I will get more in the future because why the hell not? And I am actually running the Yeti 400 battery on this system. I just gutted it. So I will actually upgrade the battery. I'm going to get a 1200 watt hour lithium iron phosphate LiFePO4 battery, and I'm going to put that in here, and that's going to be my primary battery. So that'll be cool. I'm really excited about playing with that. But what I wanted to do is I wanted to set it up with a 400 watt hour cheapo battery, because like the batteries for the Yeti 400 only cost about $100, right? So I wanted to see how this system performs on the smaller battery, so that if I screw something up and I kill the battery, I'm only out $100, right? The LiFePO4 batteries cost, for a 1200 watt hour battery, they cost about $1,000. So I really don't want to screw up that battery if I can help it, because it's very expensive. So that's why I have it set up the way I have it. I've got my 300 watt inverter that I bought to replace the inverter that failed on the Yeti 400. Both the inverter and the Midnite Classic are on this 12-volt switch here. And so if I turn this switch, both of these turn off. I'm not sure I like that. I think I would prefer to have a switch for the Classic and a switch for the inverter and have them separate, but that's how it works right now. The inverter has its own fuses. It's got two 40-amp fuses that kind of came with this cable that I bought. That's the only cable that I bought. I made all of the rest of the cables. There's also I believe it's a 180-amp fuse. I might be wrong about that. It might only be a 100-amp fuse. There's a large car audio fuse. I think it's like a Rockford or something inside the case, and I'll open that up in a second and show you. This is my Victron battery monitor. It's a BMV 700, and this thing is really, really cool. It gives you a fuel gauge, and unlike the Yeti 400, You know, it actually gives it to you in tenths of a percent, which is really, really cool. So you get to accurately see how much power you have, how much, you know, how much you're putting in, things like that. If you press up here, it shows you the amp hour draw. Not sure that's right. Not sure that should be negative. Ah, that's how many amp hours I've used since the battery was full. I've had this system set up for about 2 days now, and I haven't actually gotten a full charge on the 400 watt hour battery yet, because I'm getting so little light for so little time. So this is not accurate right now, but it gives you an idea what this meter can do for you. This is the amperage that's going into the battery right now, 0.36 amps, and this is the battery voltage, 13.01 volts. And the charge controller says the same thing, roughly, 13 volts. And it actually says that it's putting in 0.8 amps, but the power meter says it's only 0.37 amps. So I think the charge controller itself pulls its power after this number here. You really don't want to trust these numbers up here. You want to look at the battery meter. This is a hours of runtime. Like if you've got a constant load on the inverter, say you're drawing 25 watts or something, or 35 watts or whatever, this will tell you how long you have left before your battery is drained. Now, I don't think that it has a depth of discharge setting. So like, yeah, so right now with the Midnite Classic running, before the battery is completely dead, we have 240 hours because it's not actually putting anything in. It's in the resting state right now. So that's pretty interesting. When I originally wired this up, I had the Victron battery meter on the switch as well, but I had to take it off of the switch because this percentage of full, this state of charge reading, gets reset every time the power gets reset to the meter. So I had to change it so that the power is always on to this meter. And I'll show you how the switch works right now. I'll just reach in here and turn it off. And normally that would shut off the Midnite Classic, but since the Midnite Classic is drawing power right now from the solar panels, it's still on. But it doesn't know, it's not connected to the battery, so it switched over to absorb. It doesn't know what it's doing. So there we go. I just disconnected the solar panels there. I think that's generally a no-no. You really don't want to like disconnect these when they're hot. It's preferred to switch them off first, but I'm not drawing that much power. It's fine. You can see when you turn that back on, the Midnite Classic turns on, and it just goes through like a boot-up sequence, just like a PC would, right? The fans spin up, the LEDs blink inside the chassis. And then it's like, hey, I'm waiting for, you know, for a signal or something. The other cool thing about this charge controller is that it'll do wind, hydro, or solar. And right now I've got it set up for solar, but if I go over here to mode, I've been doing a couple of videos lately about the bicycle generator that I've been building, and that is built now, so I just have to film the video about it. I can use this charge controller to charge up the battery from the bicycle generator. And so what I do is I just, in this charge function here, I hit down and I can set it to wind track. And when I hit enter there, now it's set up for wind mode. And I can actually modify my power curve for the wind turbine, or in my case, a bicycle generator. And that controls like how many amps it draws and things like that. At low power levels, like 14 volts coming in from the bicycle generator, I don't know, this doesn't do a whole lot for me. But I think I'm pretty sure that it would work really well for higher voltages and wind turbines. Switch that back over to solar because I'm not using the wind at the moment. It's got a bunch of different modes. And I'm using mostly the stock settings with this. I might have tweaked one or two things, but for the most part, it's all stock because I'm running an AGM battery. When I switch this over to a LiFePO4 battery, I'm going to have to start using the auxiliary outputs to switch on and off the charging based on the charge state of the LiFePO4 battery, because LiFePO4 batteries don't like float. They don't want you to float charge them. It'll destroy the battery. The LiFePO4 battery that I'm going to buy is going to be like an ultra energy battery. I think that's the brand. And it's got a battery management system built in, and I think it's got some outputs or something. There's a way to tell if it's fully charged. And if it is, I'll just switch off the Midnite Classic via like the aux 2. I exchanged a couple of emails with them about that, so I'm fairly confident that I can make that happen. Okay, so let's turn that off and we'll open up the case and take a look inside. Oh, actually, before we do that, let's talk about this case a little bit. This is a Home Depot Rigid brand Pro gear cart. The equivalent of this case, in my mind, in a more expensive name brand, would be the Pelican 1440 case. Now, the Pelican 1440 is quite a bit taller. It does also have a handle. It's got smaller wheels than this. It's quite a bit taller and it's quite a bit more narrow. So on YouTube, you can look it up. I think they call it LFP 100 Pro. There's a guy who makes LiFePO 4 battery systems inside a Pelican 1440 case. Just like this, he uses a larger wattage inverter, and he disassembles the Midnite Classic, and he takes this, because this faceplate here is just removable, right? So he takes like this faceplate and he removes it and he puts it separate from the rest of the items. So, you know, he'll have like the battery meter and like the faceplate for the Midnite Classic right there, and then he hides the rest of it underneath the case. That's fine. I mean, he makes really quality stuff from what I've seen. Let me tell you, if you're looking at buying one of these, his system costs like, I want to say it's like $3,700, something like that, maybe $3,800. They're very expensive. However, this system, when I'm done with it, will have cost about $2,000, $2,500, somewhere in there. So let me tell you, the labor involved for cutting this wood sub-platform was way, way more extensive than I thought it would be. I cut all of this on my table saw and my drill press, because I've got these brass screws countersunk in here. I probably spent a week of evenings working on that, and that doesn't count the amount of time that I spent crimping cables for Anderson connectors and, you know, all of that stuff. I got most of the wire crimping done in like an afternoon, right? So that was very quick, but the woodworking aspect of it took a long time. So this LFP 100 Pro guy, you know, he does like, they're like water jet cut or CNC routed or something. I mean, they're really nice, well put together systems. So if you want to save a little bit of money, you can build a system like this. I mean, I've proven that you can do it, but don't think that it's going to be easy. It's a very complicated process. Like I had to measure the interior dimensions of this thing very carefully. You know, it's wider here than it is over here. This is more narrow. And so some of these pieces are trapezoidal, like they'll angle inward a little bit. Also, the bottom of this case, it either tilts down or it tilts up. I don't remember. I think it tilts up towards the front here. So, you know, I had to cut angles in my support pieces and everything. I mean, it was a lot of work. There was a lot that went into this. And then you got to have the right tools too, right? You got to have like countersink bits, drill press probably if you want to do a nice job. You know, I guess you could use a hole saw, but you'll probably make nasty work out of it. So it's killing me that I don't remember the name of those. Anyway, yeah. So, you know, you've got all this tooling expense that you've got to have if you want to be able to make your own. And then, you know, mine ended up being not as nice as his, you know? I mean, it's functional and I'm fine with that, but his is quite a bit more polished. And in addition to the 120 volt AC output, he's got DC outputs on his as well. I don't have any DC outputs on this system. So I will probably change that at some point in the near future, and I'll add some DC outputs, but yeah. Anyway, this case is really cool. It's just like a Pelican case in that it comes with these locking lids. It's completely removable, which I actually kind of like. It's got this weather stripping on it, so it'll actually seal out moisture. However, in order to actually charge something, I have to run the cable out of the top of the case. So the LFP 100 Pro guy, he has some waterproof connectors that he cut holes in the side of the case and sealed them. I might do that myself at some point. All right, so this will hopefully give you a better view. It's not perfect, but I think I can point out all of the major components here. So this is the back of the switch, and I've got power coming in from the Midnite Classic and also going out to the inverter. on one of these rails, and I'm not going to touch them right now because they're hot. 12 volt, I probably wouldn't die, but there's a lot of amperage there. I don't want to mess with it. This cable here goes to the Victron battery meter, and it actually comes around and plugs into this shunt. And the shunt is on the negative end, the switch is on the positive end. None of this stuff is grounded. I think that's okay from the people that I've talked to that actually know about that stuff. This red cable here goes into the shunt, and it latches onto the positive end of the switch, the 12 volt switch. So this red cable is what supplies constant power to the battery meter through the shunt. So it powers up the circuitry on the shunt and also powers up the head unit. So this particular bolt right here is always on, right? And then this is the one that's switched. And so that's the one that goes to the Midnite Classic and the inverter. Now here I have, well actually let's work our way up. So this is the hot end, this is the always on end, right? And here I've got that Rockford 100 amp or something fuse. I don't know, I don't remember the amperage. I remember that I sized it so that it would protect this 4 AWG wire. This is 4 gauge wire. In other places on the system, like over here, I use 10 gauge wire to go to the solar panels because that's more than enough. That's actually what PV cable usually is. It's usually 10 gauge. But on the battery itself, because it could be handling more current than the solar panels, I use 4 gauge, and that should be fine for what I'm doing. You can use a larger gauge if you want to. I thought it would be overkill in this case. This is a Anderson connector, and you can buy these in different colors and different sizes depending on the amount of voltage that you're going to be running. The yellow Anderson connectors are for 12 volt, I believe. I don't remember the amperage that this thing is rated for, but I think it's something crazy high, like 180 amps. So this is my battery disconnect. If I need to disconnect the battery from the entire system, say I need to like swap batteries out, or I've just got a problem and or I'm working on it. Say I'm working on these wires. This is a quick disconnect, just like the other Anderson connectors. I can just pull this apart and I'm done. This is my battery. This is from the Yeti 400, and it's got these top mount lugs here, which are not very tight. I need to tighten that down. Holy crap. Good thing I opened that up. So I was working on this the other day, and I must have loosened up these connectors and not retightened them all the way. I don't know why the hell I would do that, but I'm shocked that it was actually working without these being tight. Yeah, they're both loose. Well, you know what they say about working with electricity. It either works and everything's fine, or you burn your house down one day. Anyway, okay, so now that that's attached securely, Christ. So this is my Yeti 400 battery, 4 gauge wire. Nothing is attached to this other than the 4 gauge wire. I think you're normally supposed to run this positive battery meter cable from the positive end of the battery, but I thought it would be okay to run it from the switch instead, because there's probably not that much of a voltage drop across the 4 gauge wire to the switch. Maybe I'm wrong about that. I might end up killing a battery for doing that, but the advantage is that I can swap out my batteries if I want to pretty easily, or work on the system. There's also this blue cable here is the temperature sensor for the Midnite Classic, and it attaches way down here on this side of the battery. It's right over there on the side. It's got, charging, temperature sensing, and all that stuff. These are my 2 supports, and these are just, what is that, like 1-inch wood? I don't know, 1/2-inch wood, something like that. It's thin, like shelving material, right? And then once I measured it for the height that I wanted so that the lid would close, I attached these stops with screws. Everything else in here is either brass screw hardware, or I've got like dominoes. They're like these little tenons that you cut with like a drill kind of thing. It's a Festool domino machine. So a lot of the backside of this plate is dominoes, and this is like 1/4-inch plywood. Yeah, that's pretty much it. Down here at the bottom, there's I think it's 2-inch building foam, rigid building foam, and this is an insulation material. I put this in here to secure the battery so that it wouldn't wobble around or anything. And when I put a larger battery in here, I'm gonna have to cut out a new piece of this. But that's the only thing that I'm gonna have to change for the new battery. So that's pretty cool. I had originally intended to fill this up with foam all the way and not use these wooden supports at all. But then I got to thinking about it and I was like, man, that might be okay in the winter, but in the summer, it's gonna, the battery's gonna create too much heat and it's gonna cook my battery. So instead, I just used a little bit of foam on the bottom side and the rest of it is open so that it can air cool. None of this is airtight. I do worry with an AGM battery. I worry about hydrogen collecting in these little pockets here. I don't have a proper venting system set up. I think you're supposed to use like 2 copper tubes, one inside the other, to vent hydrogen properly. I'm not really charging the battery up to full capacity yet, and when I do, I'm kind of careful about it. So, I'm expecting it to be okay until I replace it with a lithium iron phosphate battery. That's the inside of the system. I mean, it's pretty straightforward, but man, building this stuff will really cost you a lot of time. You wouldn't think that it would because it's just a platform on some wood, but it is very time consuming. So approach a project like this with caution. If you're like me, it might make sense to just buy a ready-made product like the LFP 100 Pro. I enjoy knowing what went into the system and being able to work on it myself, so this was the right choice for me. If you just want a ready-made system, I recommend just buying one instead of making one because it's a lot of work. So let's put this back down. Slide that into place. There we go. Just sits back down on there like that. Hook up the solar again. Turn that bad boy back on. All right, this is Jesse with Create This. If you want to buy any of these components that I have bought, I can't offer links to all of them down below, but the ones that I can offer links to are down below in the description. So if you want to pick up like a Midnite Classic or this inverter or this battery meter or even like switches or things like that, I'll have links down below in the description. Those are affiliate links, so if you click on one of those, I get a small commission, but it just helps me support the channel so that I can continue buying cool components like this and showing them off on the channel here and making cool videos. Hopefully you learned something or found this interesting. Maybe you had some ideas for your own projects. If you have any comments for me, I'm not an expert, I'm only a hobbyist. So, if you have any comments, if you see anything that I did wrong or that I should do or that I should change or that I could do better, leave me a comment down below. Don't forget to click the like button. Thanks for watching and please subscribe.